All right, we are on the last lesson of the chapter, 7.5. And it's over ellipses and hyperbolas. So an ellipse is kind of like just an oval. So on this first one, the major axis is the x-axis because it appears to be longer. And whatever the major axis is, that's where the vertices are. So the vertices are A0 and negative A0. The covertices are on the other axis, and we're going to call those B. So 0B and 0 negative B. Excuse me. Okay. Oh, and then I forgot the equation. I'll do that in a second. Let's move on to the other one. This time, since the major axis, since the y-axis is larger, then the y-axis is the major axis. So the vertices would be on those, which we call A. So 0A, 0 negative A. And the covertices would be on the other axis, which in this case would be B0 and negative B0. Okay, let's do the formulas, or the equations. Okay, so the equation for both are going to be similar. So I'm going to have x squared over something plus y squared over something equals 1. So whichever one is the major axis, since the x is the major axis, that's where a squared goes. And on this one, since the y-axis is the major axis, that's where a squared goes, under the y squared. So whichever axis is the major axis, that's where you put the a squared under. Okay, so just to summarize, vertex we're going to call A, covertex we're going to call B, and then as a reminder, the focus is C. We'll get to that later on here in the notes. Okay, so the first question, I want to write an equation in standard form, meaning one of these two, where the vertex is 0, negative 6, and the covertex is 3, 0. All right, so I'm going to go and do x squared plus y squared equals 1. Since negative 6 is in the y spot, I'm going to square that and make it 36. That's going to go under here. Since this number is in the x spot, I'm going to square that and put it under x squared. And now I'm ready to graph. And really I could have graphed first. It doesn't really matter. So I'm going to graph this point. And then I'm going to graph this. Whoops, I did that wrong. It's down here. So there's that point instead. That's not really there. And then 3, 0. And then I can get the other two. So if this one's 0, -6, the other one is 0, +6. And if this one's 3, 0, the other one's -3, 0. And then I'm going to connect. Okay, that's the first page. Okay. Okay, this is just like number 1 on the previous page. So I'm going to go ahead and, let me graph it first this time actually, because it doesn't really matter. All right, so I got 3, 0, and 0, -1. Well, I can very easily get the other points. If this is 0, -1, the other one is 0, 1. If this is 3, 0, the other one's -3, 0. And then I connect. All right, now I'm going to make an equation. So it's always going to be x squared plus y squared equals 1. And then since this is in the x spot, I'm going to square that and put it under x squared. This is in the y spot. I'm going to square that and put that under y squared. Now really I don't need that one, so I also could write it like this. Okay, moving on. Now these two are similar, so I'm just going to do number 3. Okay, so it says again to find the equations. I'm going to go and start it off like this. Okay, I'm going to make a little sketch over here. It says that the ellipse is 20 units wide, so maybe from here to here is 20. If all of this is 20, that means that half of it would be 10. And then all of this from here to here is 10 units high, which means from the origin up would be 5. It's going to look something like this. So this is 10, and that's 5. So since this is on the x-axis, I'm going to square that and put that under x squared. This number's on the y-axis. I'm going to square that and put that under y squared. So that is my answer to that one. And again, we're skipping 4. It's just like number 3. All right. So now we're going to talk about the focus, or in this case, the foci. That's plural for focus because there's going to be 2. And all I really want us to do on this one is that to find the foci of an ellipse, you're going to use this formula. Okay, now remember the foci, or the focus, is C. So I'd eventually have to take the square root. All right, so I'm going to use this formula. Now, if you're not sure which one is a squared or b squared is always the bigger number. So I'm just going to go ahead and take 81 minus 36. You should never get a negative answer. You get 45, but I want to know what c is, not c squared. So we're going to take the square root, and it's going to be positive and negative. And I can actually simplify that. I can make this the square root of 9 and the square root of 5. The square root of 9 is 3, and the 5 stays underneath. Now I have to decide how I'm going to write this ordered pair. Since the bigger number is under the y squared, this goes in the y spot. Okay, let's do the next one. So I'm going to take a squared, a squared minus b squared now I gotta know what just c is. And I can't really, I think I can simplify that actually. That's gonna simplify to 9 times 13, I believe. Yeah. Oh, and it's positive and negative. So positive and negative 3 square root of 13. And this time, the bigger number is under the x squared. So that number is going to go in the x spot. Okay, that's how you find the foci. You just use this formula right there and then make it an ordered pair. Okay, moving right along. So now we're going to write an equation of an ellipse given the foci and the covertices. And it's actually in that order. The foci is given first and the covertices are given second. And remember, I told you on the first page that the foci is C and the covertices is B. So this would be C and this would be B. Okay, so I'm going to go ahead and start writing my equation for the ellipse. Well, I have to use, whenever I'm given the foci or you want to find the foci, if foci is ever involved in a problem, you want to use the equation that I gave you on the previous page. Well, since C is 4, C squared is 16. I don't know what A squared is. B is 2, so B squared is 4. If I add 4 over, I get that A squared is 20. Well, now I have to decide, does 20 go under here or does it go under here? If I go back and look at the covertices, this B, which is the covertices, that's in the X spot. So the B squared, which is 4, goes under the X squared. Because again, that number is in the X spot. The 20 goes under the Y squared. Okay, next one. So again, I'm giving these to you in this order. This is the foci, and those are the covertices. So I need to make an equation. All right, let's look at this first this time. The B is in the Y spot. So if I take 1 and square it, I get 1 still. Since it's in the Y spot, it's going to go under there. So I kind of did this first instead of last, like I did on the previous problem. Okay, C squared. If C is 3, C squared is 9. I don't know what A squared is, but I know B squared is 1. If I add over the 1, I know A squared is 10. So 10 must go there. And whenever 1 is the denominator, you don't really need it. So here's another way to write your equation. Okay, so those are all of the ellipses. Now we're going to talk about hyperbolas, which are just a fancy name for butterflies. Let me draw on the XY axis. Okay. I'm going to give you an example. So I'm going to give you a formula, and then we're going to graph it. So it's very similar to the formula for an ellipse. The only difference is that it's minus instead of plus. Okay, so here's what you're going to do first. So these numbers are squared. So I need to take the square root. So I'm actually going to get 5 and 2. So on the x-axis, I'm going to get rid of 5 and over to -5. And then on the y-axis, I'm going to go up 2 and down 2. And if this was plus, I would go ahead and make my ellipse, but it's not. So what I need to do is I need to graph this very exact as possible. So what I'm going to do next is I'm going to make a box out of this, but I'm going to make it dotted. And then I'm going to draw diagonals through the corners of the boxes and through the origin. And since x squared is first, I want the points that are on the x-axis, and I want to stay within these dotted lines. Because on a hyperbola, sometimes the y's might be first. Okay, so there's that one. Okay, here's the second example that we're going to use. So this time I'm going to put y squared first. Okay, so in the formula, these numbers are always squared. When I graph them, you want the square root. That's going to be 4 and 3. On the y-axis, I'm going to go up 4 and down 4. And then on the x-axis, I'm going to go over 3 and down, and over 3 to the right and over 3 to the left. If this was plus, it would be an ellipse, and I could just go ahead and connect it. But since it's minus, it's a hyperbola. So I got to now graph exact as I can, as much as possible. So I'm going to draw a dotted box, draw diagonals through the corners of the box. And since y squared is first this time, I want the points that are on the y-axis. And that's how you graph a hyperbola. Okay, now these two questions are just like what we just did, so I'm just going to cross those off. Okay, now down here, I want to find the foci of the hyperbola. It is an equation, but it's different from what I gave you for the ellipse. For the hyperbola, it's opposite. It's going to be a squared plus b squared. The ellipse was a squared minus b squared. So it's kind of the opposite of what the sign would be in their original equation. So if their equation is minus, their foci formula is plus. Okay, so I'm going to go ahead. I'm going to take a squared plus b squared. A squared is the bigger number. Okay. If I add those together, I get 85. And then if I take the square root, I get positive and negative square root of 85. All right, now this one cannot be simplified anymore, so I'm ready to make my ordered pair. Now this time, it doesn't matter which one's bigger. It's which one is first. So since x squared is first, this goes in the X spot. So that would be my foci. This time, y squared is first. So when I'm finished, the answer that I get is going to go in the y spot. So we're going to take a squared plus b squared. Now I want to take the square root. I can actually break down 104. That's going to be 4 times 26. The square root of 4 is 2. 26 is not a perfect square. And that number goes in the y spot, not because its number is bigger, but because it's first. So you have to really be careful on this assignment because ellipses and hyperbolas are so similar you might get them confused. So you have to really pay attention to the signs.